it's an ethics, so it's like a mission to get here.
Okay, we're gonna start now. This is the last class meeting of the Fish 507 age-structured stock assessment models. I will be in touch with you about your final assignments. I'll probably do that later today. We have a guest speaker today, Patrick Cordue from New Zealand. We were lucky to catch him in Seattle. He was here for a Committee of Independent Experts review. Patrick is trained as a mathematician. He started to work for the New Zealand Ministry of Fisheries in 1987. Then when did NIWA, I mean, in about 93 or so that NIWA was cast off from?
Something like that.
Anyway, somewhere in the mid-90s, New Zealand took all of its research labs and removed them from formally being government departments and made them what are called Crown Research Institutes, which is basically turned them into a consulting company owned by the government. But they still continue to do about 90% of the fisheries work, and they did this not just in fisheries, they did it in agriculture and all across the whole landscape. And so Patrick worked for what was then called NIWA, National Institute for Water and Atmosphere, through to 2000, when he basically went private, as many people in New Zealand seem to do. And Steve has learned, has followed that path now. And he's been working as a stock assessment consultant ever since, both in New Zealand, doing a lot of CIE reviews here, and I'm sure lots more. For at least 10 years, Patrick and I sat across the table from each other doing competitive assessments of particularly the hoki fishery in New Zealand. He's recently sort of the Orange Roughy quota holders in New Zealand wanted to get MSC assessment. They had a pre-assessment, and one of the deficiencies was there wasn't a stock assessment that had actually been approved through the New Zealand process. That there were just a lot of issues in the stock assessment. Patrick was contracted to really look in and do try and figure out if we could get an assessment of Orange Roughy that would stand up to outside criticism, and internal and external criticism. And he succeeded at that, and the Orange Roughy, 3 of the Orange Roughy stocks have now been approved by the MSC for certification. They are in the process now waiting for objections, of which there will undoubtedly be some, because Orange Roughy has been such an iconic species. And he's agreed today to tell us about the, this stock assessment and what problems there were along the way, why previous assessments failed, and they've now got an accepted stock assessment for several of the New Zealand stocks. So, over to you, Patrick.
Thank you, Ray. I'll get straight into it. Phone page down.
That's the one. Okay. Well, why isn't that?
That's all right. It'll probably work now, except on the slide.
Okay.
Yeah, I have my laser pointed down. Okay, so first I'll go over the presentation structure. I always start with acknowledgements so they're not forgotten. An introduction of who I am, which is Ray has just done. I'll tell you a bit about New Zealand Orange Roughy, just to introduce it, and I'll introduce the stock assessment package that I used. It's a package NIWA developed called Castle. I'll run over the stock assessment problems that we had for decades, and then I'll go over what I've called the keys to success, how I managed to actually get some successful assessment. Now, the acknowledgements, MPI, that's Ministry for Primary Industries. So that's eventually where the government fisheries management ended up, along with other stuff. 2013, they funded ISL, which is my company. The company is me, just me, to do an assessment of Mid-East Coast Orange Roughy. Niwa had tried that in 2011, it hadn't really worked, and they needed it. MPI came to me and I did an assessment, and that was really the first successful model-based assessment that had happened for Orange Roughy in New Zealand since before 2008. And, I'll show you why that happened. We had a period where we just did not do model-based Orange Roughy stock assessment, which sounds crazy, but that's what happened. Because I was successful in 2013, I got a phone call one evening from George Clement, who was wandering down the street with Andre Punt. And George said, "Oh, can you come to a meeting tomorrow morning? Andre wants to ask some questions." I said, "Okay." And he said, "Oh, and by the way, can you do 4 Orange Roughy stock assessments for us this year?" And I agreed. I'm not sure I should have. 4 in one hit is pretty tricky. Niwa make their package available for anyone to do stock assessment, and that's great. So I do acknowledge Niwa for that. Who I am? Well, Ray read this slide. It was.
Sorry, just a second. Oh, we got to share the screen.
Oh,
Okay. Sorry. My where's the share screen? Right. What's it say? I can't read it now.
it says stop sharing your screen.
No, I'm on. Okay, I got to
Share your screen.
Okay, sharing the screen. Okay. All right, that should do it. My fault. Okay.
Okay, so in '87 it wasn't actually the Ministry of Fisheries, it was Ministry of Agriculture and Fisheries. Then Fisheries got split off, then the research got split off and that went into Niwa, and the management stayed with the government and the ministry. So yeah, I did leave in November 2000 and I worked on a contract, and yeah, a bit of CIE work. I just counted them up. I'm now writing my 32nd CIE report. So I've been doing that a while. Now, just a little introduction to New Zealand Orange Roughy. The first fished commercially, spawning aggregations in winter on the North Chatham Rise, 1979, in water deeper than about 750. A TAC was actually set very early there, in the early 1980s, 23,000 tonnes. It used an M of 0.1, which we now know is a bit high, but it also just used trawl survey estimates. They were taken as absolute biomass, and they set a TAC on that basis. Now, of course, they didn't really know the Q for the trawl survey, but they just said, okay, we do, and they used it and they set quota. It wasn't until 92 that a realistic value of M was used. So that's more than a decade of really too high natural mortality assumed. The largest fisheries, East and South Chatham Rise, Challenger Plateau, which we call it Orange Roughy 7A, and Northwest Chatham Rise. I've got a map on the next slide, and I'll show you where they are. The current catch limits, well, they now range from 1,000 to 3,000 tonnes. So on the Chatham Rise, we're talking about much reduced catches. That actually got up to 30,000 tonnes for a decade on the Chatham Rise. Estimated stock status for those 3 stocks isn't too bad, and these are the 3 that were put forward for MSC certification. The target range then was 30 to 40% B0, and East South Chatham Rise just snuck in, but the other 2 were quite comfortable. And Ray asked me to write a New Zealand Orange Roughy classic fisheries story. It's available on that website here, which covers more of the history. Whereas this talk, of course, is much more about technical matters. Here is the map I mentioned. So you all know what New Zealand looks like. We've got a very big EEZ because we have strategically placed islands. The Chatham Rise is a large area, sort of 200 to 800 metres depth. When you go deeper, you get into Orange Roughy. So if you can see that box there, that is northwest Chatham Rise, and in the dark blue is where the fishing occurs. East and south Chatham Rise, we go over here and then down around the corner, and that's the biggest fishery. The spawning box, which I'll talk about later, is up here on the north. Mid-East Coast is as advertised. It's bottom of the North Island all the way down to the top of the South Island. Orange Roughy 7A from the Challenger Plateau. It actually includes Westpac Bank, which is outside the EEZ, but we assume that's the same stock. And then there are other areas where there are Orange Roughy found. There used to be a fishery, Cook Canyon, West Coast, South Island, some fishery off Pusica. They've had time to rebuild. There's certainly investigations going on to look at if the biomass has come back sufficiently to fish them again. Now Castle. I could have done without Castle, but I would have had to just write my own code. The code was already written. It's the advantage of a package. Niwa developed it in 2001. It was because I left. The stock assessments were being done using software I had written. I left, so they had to do something new, and they developed a really good package. Now it implements Bayesian stock assessment, and that is not just minimisation to find the mode of the joint posterior distribution. Yes, we have to do that minimisation. It's good to look at what we call the MPD estimates, the diagnostics, and also give you a starting point for doing your MCMC chains. SS3 are written using ADMB, which is built on the auto diff libraries. There's also some other libraries for doing automatic differentiation, ADOLC, and that's what Castle is built on. We have this standard Metropolis Hastings algorithm for MCMC. Our point estimates are the median of the marginal posterior distributions, and then we get credibility intervals, again from the marginal posterior distribution. We go all the way through to the MCMC because we've found on many occasions that the MPD estimates are not in the middle of the marginal posterior distribution. So the approximation for credibility intervals that comes out of SS3 from the MPDs could be very bad in terms of approximating the true MCMC estimates. Sometimes they'll be spot on, but sometimes they'll be dreadful. An important part of Castle is what we call the partition, and it's basically a counting system for fish numbers. You can think of it as a multi-dimensional array. The good thing about in Castle is it's user-defined. So you can specify as many stocks as you like, as many areas as you like, and the partition is built to account for fish, to keep track of the numbers of fish by stock, by area, by sex, by age, and also if you include it in the partition, maturity. So you keep track of the numbers of fish that are immature and mature, and you have a maturation ogive. Fish move from the immature cell to the mature cell, and they stay there. This is quite different from specifying a fixed proportion mature at age, which is constant across time. If you have a fishery targeting mature fish, proportion mature at age is not constant across time. So that's not what you want. You want to have maturity in the partition. So the models can be age structured and you just produce length when you need it, just like SS3 does, or you can have purely length structured models. Annual cycle, again, this is user defined. So you can put as many time steps in the cycle as you like. So you can set up fisheries on specific areas and seasons. You put the migrations at the time you want them, put maturation when you want it, and so on. And of course, that you can then put observations exactly where they belong. If you've got a trawl survey in a particular area at a particular time, you'll have that area in your model, you'll put that observation in the right area at the right time. There is excellent documentation, and I don't think anyone would disagree that the user interface is much friendlier than finds with SS3. Okay, I'm on to Orange Roughy problems, and these occurred over decades. Biomass indices. Okay, if you want to do a decent stock assessment, you've got to have some idea of how biomass is changing over time, or the scale of the biomass. The trawl surveys initially were used as absolute biomass estimates. We know that's bad because you don't know what the Q is, you don't know what the scalar is. By 89 they were acknowledged as just being relative, but then in the mid-90s monitoring of trawl surveys went to custard on the Chatham Rise in particular. So, acoustic survey.
You might want to define what going to custard
Went to custard. Yeah, it was an expression first used in New Zealand on a talk show. Basically, things were good, and then it liquefied. It just went it went bad. And you'll see how it went bad. I've got a slide on that next. Now, acoustic survey started really early. The equipment wasn't great, but there was an acoustic survey of Orange Roughy on the Chatham Rise in the mid-80s. But we didn't know what the target strength was, and in fact that proved very problematic for a long time. Now, acoustic survey, you know how much energy you put into the water, you listen for the echoes, you know how much you got back. To get a biomass estimate out of it, you need to know on average how much energy a single Orange Roughy reflects. That's the target strength. It was known to be very low because their swim bladder is filled with waxy ester rather than gas. Even though the target strength wasn't known well, they were used as absolute biomass estimates. Again, not a great thing to do. Daily egg production surveys. The spawning season was a bit long for annual egg production. So daily egg production was tried in the 90s. It didn't really work. The assumptions were never met. There was meant to be one spawning source, and suddenly we discovered there were two spawning sources, and then we estimated the mortality of the eggs, and it was negative. Things, again, went to custard. But nevertheless, they got included in stock assessments as absolute biomass estimates, but typically there would be a large CV put on, so 70% or something, which begs the question, why would you put it in? With all the fishery independent indices having their problems, of course, people then resorted to standardised CPUE. Now for spawning aggregations, I mean, there's an obvious problem of hyperstability. So your catch rates depend on how you fish the aggregation, not on how much biomass is in the aggregation. But for hill fisheries, we appear to have high depletion. And that is, you'd find a new hill, you'd get really high catch rates, but 2 or 3 years later, the catch rates were really low, and they stayed low. Now this is just one hill or one hill complex. It's hard to believe that's monitoring the whole stock biomass. And I've got a slide on that, and most people now, I think, accept we've got high depletion with regard to CPUE indices on the hills. Here is how the trawl surveys went bad. So this is East-South Chatham Rise. There were 3 vessels involved in the time series of trawl surveys. So the first 4 points of $1 a year, starting in the mid-80s. And Yeah, it looks like you've got a useful monitoring tool here. Like catch was being taken, the trawl survey index was going down. Thing to remember is this was a trawl survey during the spawning season on the spawning grounds. So this is not ideal for a trawl survey when you've got fish pluming up in very high density. It was a change of vessel, and it looks like it was a change in efficiency because we stepped up, and then that carried on going down, and that looks fine. Then the NIWA's research vessel Tangaroa was used. The first point in the series doesn't look too bad, but there were some warning signs there with the sex ratio that started being skewed towards females. This survey had a CV of about 65% on it, and the sex ratio was highly skewed. The males were missing. Just weren't many of them at all. And, the high CV is to do with a reduction in spawning biomass and the catch rates being much more hit and miss than they were in the early days. But in terms of a monitoring tool for spawning biomass, trawl surveys have failed by this time. So what about acoustic surveys? Okay. Think. The screen is thinking. Right, acoustic surveys. Again, this is East-South Chatham Rise. I have 3 columns. There's old plume, there's Cordue, which I also call the new plume. There's a crack, which is also called Mount Muck. Okay, I didn't have great alternatives. Now, a lot of these acoustic surveys were direct funded by the industry, and they were following the old plume. We knew when spawning was, we knew the general area the old plume turned up in, and the survey design was to go there, survey the aggregation, that's one snapshot, do it again, multiple snapshots. Some of these years there are 10, 15 snapshots, and the index is the average of the snapshots. That's why these CVs are so low, because you're averaging multiple snapshots. Now this was a predictable location. They went there, they surveyed. You can see a bit of a drop in the first year, but things held up pretty well until they started trending down quite dramatically. There was a lot of concern in 2008, 2009 period about this. This was treated as an index of the spawning biomass for that stock, and things were not looking good. Strange thing happened in 2010. The fishers noticed that there was another spawning aggregation about 20 miles away. They said it was big. It wasn't surveyed that year, it was surveyed the next year. And it was big, and it had almost twice as much biomass in it as the old plume. That year they also surveyed the crack. We always knew about the crack, but actually there's quite a bit more biomass there than we thought there was. So this was a problem. It couldn't be argued that this was indexing the spawning stock biomass anymore. This plume had been there for some period of time. We don't know how long. I did do a run where we had a hypothesis that it had been there forever. But if you argued that, so it was sort of a staging post, younger fish would go there and spawn, and when they got older, they'd move on to the old plume. But that hypothesis led to over 100,000 tonnes of biomass in the late 80s in the new plume. Now that would have been noticed. In the base model, I think we have it coming in at 2002. Problem is this is no longer indexing the stock, so there's not a lot of information in this time series anymore. The information is in these later years. We believe we're estimating most of the spawning stock biomass. CPUE. The black dots are the catch rates. They have confidence intervals. The dashed line is the catch taken from the area. The top two are the spawning box, and this is pre-closure and post-closure. The spawning box was closed for a few years in the mid-90s. So they're fishing on spawning aggregations. There's some evidence there that, basically it's fairly flat. This big jump down has probably got something to do with them fishing it differently in terms of quality. They don't want such big catches. I mean, if they find a spawning aggregation, you can take whatever catch rate you like. Post-closure, it's definitely got something to do with wanting better quality fish, just taking lower catches. They knew where the spawning aggregation was. If they targeted it, they could take 20, 30, 50 tonnes if they wanted to. They didn't. Eastern Flats, we've got this downward trend early on in the 80s. So that looks bad for the stock if that's indexing the stock. Series of hills, high catch rates when they first find it, first focus on it. So they find a period of the year when they can get high catch rates, but then catch rates plummet and they stay low. That happens to lots of different complexes. These are further south, they were fished earlier, plummets, stays low. If you try and put these hill ones and these eastern flats in a stock assessment model, you get nowhere because they are saying, well, the stock plummeted here and then it plummeted again. Oh, it plummeted earlier as well. I mean, basically it looks like these are indexing some sort of local abundance. Because they make no sense as whole stock indices. Okay, so we didn't have any biomass indices, but things got worse. We had ageing problems. So you standard approach, here bones, chop, cut them, read the, count the rings, annual rings in the otoliths. There was some validation the first 4 years through a length-based modal analysis. It was just the first 4 years. People were still arguing about how old Orange Roughy were after that. But bomb radiocarbon, I think most people accept now Orange Roughy do live a long time. So there was some validation of the ageing by reading the otoliths, counting the rings. But they are difficult to read. There is a place in most otoliths where the rings get very close together, and that's called the transition zone. So they start off being reasonably easy to read, and then they really bunch up. The real problems arose when we had two research providers in the market for reading otoliths. So it was all NIWA for a period, and then CSIRO, which is the Australian equivalent of NIWA, were contracted to do some reading. A couple of years after that, NIWA did a study comparing across research providers and within research provider across time, and there were some big problems, major inconsistencies between the providers, and also a drift in age readings over time within providers. So there were problems with both providers. It was about 2006, age frequencies just stopped being used in the assessments. Nobody would believe them, so we couldn't use them. There was a big international workshop, ageing workshop in 2007. They agreed a new protocol, and it was all to do with the use of the transition zone. Now the Australians were typically not identifying the transition zone, therefore they were not increasing the magnification, therefore they were getting their age reads were much lower than NIWA. So there was a new protocol agreed, there was testing, there was reading between labs and across time. By 2009 there was a report saying yes, we've got a consistent protocol, we can now trust our age readings. It took a while before we started reading them again. It's what I call the dark ages, between about 2009 and 2010. We weren't using age frequencies, we weren't doing Orange Roughy stock assessment using models. We were back to back of the envelope calculations using acoustics as absolute biomass. Turned out it was reasonably conservative management, but we didn't know that at the time.
So when you went back and read them, could you like reread the historical ones, or that was only like moving forward?
Oh no, all the overlists are still available. So yeah, rereading using the
According to
new
the
protocol.
new protocol, okay.
Yeah, so during the Dark Ages, well, what brought on the Dark Ages were what was termed data-independent models. So we weren't using age frequencies in the stock assessment. So we had to assume deterministic recruitment. No recruitment deviations, you just take your recruitment off the stock recruitment curve. But that was very problematic because of our catch histories. See, early on there was a lot of catch taken, and then there was big reduction in catches. And what happens in a deterministic model, well, you've got to have sufficient mean recruitment, sufficient R0 to support those early catches so that they could be taken within the model. But then the reductions in catch were so large that R0 then meant you had to have an increase in biomass. There was no choice. And actually what happened was you got the same result whether you put your biomass indices in the model or not. So it was data independent. It was all being driven by catch history and the assumption of deterministic recruitment. So yeah, that brought on the Dark Ages where we didn't have any stock assessment models for Orange Roughy. Here's an example of the catch history, and this is for East South Chatham Rise. So the y-axis is catch. Put into the model, it includes overruns. In the early days there were quite a lot of burst bags, so the landings were not the total kill. You had to account for lost fish. The line to look at is the one on the top, which is the total over there were 4 fisheries in the model. And you can see for quite a period we're averaging 30,000 tonnes. Then there's a big decline. So to support those catches, the model had to have pretty good recruitment. But then the big decline, okay, well, biomass starts going up. Doesn't matter whether you've got data or not. Now, to my mind, a lot of, there were big problems with Orange Roughy stock assessment, not having age frequencies, huge problem. But the ageing was sorted out by 2008, 2009. We could have started rereading using the new protocol. I don't know why we didn't. But there was this conceptual model a lot of people had for Orange Roughy. And they thought that they were pretty much like any other fish, except they were longer lived and they were in deeper water. They were mobile, they swam around, they found their best feeding sites and so on. And in particular, there was this association with underwater features, which I'll just talk about as hills. And the idea is that they're demersal, so they can stay on the bottom, they can go up the hill till they reach the feed layer that's intersecting with the hill. So they can stay near the bottom, but access good feed layers. So the idea was that the hills attract Orange Roughy like they're a fad. The Orange Roughy will come to the hill and have a good feed, and they're just roaming around, going from hill to hill, having a good time. Spawning in winter they certainly do, but in predictable locations. That was the whole idea behind monitoring the old plume. We know where the spawning biomass is, it's always here. We can index the stock by just surveying the old plume. For some stocks, they certainly do undertake substantial migrations, or they appear to. If they're just coming out of deeper water, perhaps they don't go very far. But we have tracked some migrations. Now, one of the big problems was using the transition zone as an indicator of maturity. So the argument made was that the rings are getting much closer together. the fish is putting its energy into something else, maturity, it's getting its gonads ready. And transition zone maturity was predicting maturity 25 to 30 years of age. The problem with that was that if you took that as maturity, transition zone maturity, and you put it in a stock assessment model, it didn't give sensible answers because there was a mismatch between the maturity ogi from transition zone and the commercial selectivity ogi. Now, why should they be related? Well, the early fisheries were on spawning fish. So they should match up if you've just got spawning fish. The fisheries move from spawning fish to year-round operations. Okay, that means you bring in some of the immatures. So the selectivity should be to the left of maturity ogi. But if you estimated both of them if you specified the maturity ogi and you estimated the commercial selectivity in the model, the commercial selectivity was well to the right of the maturity ogi. So in completely the wrong place. Commercial fisheries were catching older, larger fish than they should have been if you believe maturity from the transition zone. So either the transition zone has little to do with maturity, or they don't start spawning as soon as they mature. There could be a delay. They mature, but for some reason there's a delay in them going off to spawn. It could be to do with food supply. They might not be in good enough condition because maybe there are bigger, older, gnarlier fish keeping them off the hills. I'm not a biologist, so you can laugh. Page down. That does bring us to the hills as hotspots.
So, Patrick, can you estimate maturity otherwise from looking at the gonads and compare that?
Well, yes, you can. Well, I'll get to that. We can. I've got some new data for 2014 to help us with that. Yeah. So hills as hotspots for Orange Roughy. Well, lots of new hills have been discovered during the development of the fisheries. And as I told you, and you saw that slide, typically what happens, high catch rate, then a decline, and then they stay low. Now, that's really the only explanation I've ever come up with for that is that there's a resident population in some sense. So, associated with an underwater feature, there are, within the region, a local population. And when you fish that hill, you're fishing out that local population. They can't act as fads because if they did, your catch rates wouldn't go down and stay down. So if they're acting as fads, it's a very slow thing. So fish are moving from where they tend to hang out to the hill if the hill's fished out, but it might take 10, 20 years. So anyway, CPUE from hills, you don't use it for indexing the whole stock. Spawn in winter in predictable locations, well, it's the predictable that's the problem. They definitely spawn in winter, yeah, there's migration. But what happened on the east-south Chatham Rails? Well, we had our old plume, and we thought it was an index of spawning biomass, but then a new plume popped up 20 miles away. So something interesting is going on. There are marked age differences between the old and the new plume, and I have the next slide will show you that. In Orange Roughy 7A, so that's the one up on the Challenger Plateau, north and east of the South Island. The plumes aren't as predictable. We've got trawl acoustic surveys that go there, and there are spots where some years there is a plume, some years there isn't. But the point about that is the plumes are not found where they used to be. So there used to be a lot of fish there in the 80s and 90s, on the central flat, and there are no plumes there anymore. They're in quite different locations, south and east. Created a bit of a problem with the trawl survey design because that was based on where all the fish used to be, and they had to keep extending the area south and east. We found them eventually. So my conclusion is somewhat of a disconnect between the recruitment to the spawning population and the existing spawning fish. So I haven't been reporting on people arriving late.
Yeah, no, that's okay. They'll be docked.
Yeah. So yeah, I mean the idea is the fish that the new ones that decide to go spawning should be tagging along with the old ones. Some of them do, but some of them don't. This new spawning aggregations appearing in different areas to the old ones. Here are the east-south channel age frequencies we have. In the top we have, this is the old plume, we have 2 years which we have age frequencies for, and they're really very consistent across those 2 years. The new plume or Rikohu, again reasonably consistent across the 2 years, but you can see that these are predominantly younger fish. So it looks like most of the new recruitment's gone to the new plume, some of it's gone to the old plume, but if you look at fish 60 years and older, there's not a lot in the new plume. They tend to be in the old plume and in the crack. As I said, we tried that hypothesis where this was just sort of a staging area for the younger spawning fish, but that didn't make any sense, that it had always been there. The base model has it developing as a new location for spawning fish. So when I was reviewing all the data that was available, the models that had been used, the data that could be made available as in new age frequencies with a new aging protocol, I had in mind a new conceptual model. And it had, this home area, so fish resident in their own home area. Yes, they may undertake a spawning migration, but they come back to their home area. And spawning fish, to my mind, well, transition zone maturity, if it related to maturity, there was a delay, and spawning fish were an older age subset of the transition zone mature. Now the consequences of this sort of model, well, you just don't use CPUE, you've got hyperdepletion on the hills. You've always had hyperstability in the spawning aggregations. You don't use transition zone maturity at all. And you just do what you normally do. If you've got the data, you estimate spawning OGI within the model, and stock status is just based on spawning biomass percent B0.
What is the data on maturity that you have within them to estimate spawning OGI within the model?
Yeah, next slide. It's the aging. So down the bottom here we've got proportions spawning at age using the new aging protocols. The other way of getting at it is if you've got only a spawning fishery, then the catch at age from the spawning fishery is giving you your maturity or your spawning OGI. So there are two potential sources. So 2014 assessments, the modelling side of things was me, but in terms of producing the data that I asked for, NIWA and MPI and the industry were all involved. So I was asked, what age frequencies do you need from a new aging protocol? NIWA did the production of the age frequencies funded by the Water Group, facilitated by MPI. Since I've got new age frequencies that people will believe, I can estimate recruitment deviations, and therefore data independence is not an issue. For some people it still was, but I demonstrated no, the data really matter. And proportion spawning at age for a couple of stocks where it didn't have dedicated spawning fish feeds, I needed that data to estimate the spawning OGI. So they've taken care of the ageing, and we don't have data-independent models anymore, but we've got to have some biomass indices in recent time to tell us what sort of scale of size the stocks are. And acoustics is sort of the last one standing. But for many years we had competing estimates of the length target strength relationship. You know, I'm wanting to get some estimate of scale from the acoustic indices. So I have to know something about target strength. I have to know quite a lot about target strength. And it was not helpful to have two competing estimates differing by a factor of about 2. So yeah, you've done your acoustic survey, and under one target strength it says you've got 100,000 tonnes of biomass. Under the other one it says you've got 50,000 tonnes. Not helpful. Again, it was Australia-New Zealand competition. Unfortunately, the Aussies won this one. 2012, there was a AOS system that was used, acoustic optical system. On the headline of the net, you put a transducer, you put cameras and video, take it down to Orange Roughy depths, you fish on the Orange Roughy, you watch the fish going under the headline, you ping on them, so you know if you've pinged on an Orange Roughy or not. So you know you've got how much energy that fish reflects. You know what length it is. You get enough fish, then you've got a good estimate of the target strength from those fish at that tilt angle distribution. That's the problem. You've got an artificial tilt angle distribution because you've herded them with the net. Great thing about Orange Roughy is their target strength doesn't depend much on their tilt angle. The echoes are not coming from a gas-filled swim bladder. So Hoki, southern blue whiting, long gas-filled swim bladder, yeah, it matters hugely what angle that's at, but not for Orange Roughy, little wax-filled swim bladder. Yeah, so this is low. They are really poor reflectors.
But this implies you're using the acoustic estimate as absolutes rather than...
But I'm not.
Okay.
I'm going to use them as semi-absolute.
Okay. The old semi-absolute.
Yeah, the old semi-absolute. And it is definitely one of the keys to success. To my mind, there really aren't any absolute biomass indices available. I suppose I might make an exception for counting the number of salmon going up a stream. But that's about it.
Make that exception.
I'll make that exception. But in the open ocean, you know, there are various methods that developed to try and get it absolute. But when you look at potential sources of bias, what I mean by that is bias away from Q equals 1, and you look at what the Q is actually made up of, it'll tip it, well, one possibility, and this does happen in acoustics, is the Q is the product of a number of factors, and they're all potential sources of bias, and it really does require a miracle that they all cancel out and equal 1. So I don't think of absolute biomass. I think of relative biomass with an informed prior on the Q. So this is a standard equation for relative biomass indices. Xi, the index, Q is the unknown proportionality constant, Bi is your true biomass that you surveyed or trying to estimate, and I used little ei as the error. I would have used epsilon, but sometimes when you swap computers, they go to custard, and you get a random symbol. So Bayesian estimation is great for this because that's one of the main ideas. You put in what you know about the parameters in an informed prior, and we know quite a bit about Q. The key is, though, of course, to make sure you put in the right stuff into the prior and the right stuff into the annual CVs. Now what goes into the prior is systematic error, stuff that affects every point in the time series. So the length target strength relationship falls into this category. If you've got your target strength too low, then your biomass estimates are too high, and that applies to the whole time series. not just 1 point, all of them. And conversely, if your target strength is too high, your biomass is too low. But we know quite a bit about target strength. I can put that into the informed prior. What doesn't go into the prior is non-systematic error. So stuff that changes year on year. Yeah, there's not just observation error. We measure observation error, but there's other stuff that goes wrong. And that goes wrong differently on an annual basis. So that's process error. That goes into larger CVs. It does not go into the informed prior. Thank you, Australia.
Is that how Australia's done it?
There are some differences in how we've approached this. Yes.
Okay.
It's yet another New Zealand-Australian competition.
But you believe you've won that one?
No, the battle hasn't been fought. That's Auckland next week.
Okay.
2 weeks away. The keys to success. So there's another slide about this, the informed prior on acoustic cue, because it is really important. So there were 2 factors that I brought in. One was the target strength, uncertainty. So it's to do with the plus or minus 1.5 dB. You have to turn it into a linear scale and do stuff. But the other issue is, well, okay, we're going to these spawning aggregations. We're doing multiple snapshots on them. But what proportion of the spawning biomass are we actually indexing? Because it's not 100%, because they're not all pluming up at the same time. And maybe we haven't got all the areas anyway. Maybe there's some smaller aggregations elsewhere. So it's not 100% that we're indexing. So this is a big question. Yeah, you don't put in calibration errors because they're small, and calibrations are done every year, so there's some measurement error, which is year specific. You don't put in shadow zone corrections because you've had a high data quality threshold. You don't use acoustic estimates from a hull sounder where the aggregation's on the side of the hill, where you've got this huge shadow zone. You just don't use those. If you're using a hull sounder, the aggregation will have to be on the flat or it will have to be on top of the hill. If they're on the side of the hill, you'd better have a towed body to get much closer to them, and you will have a correction for the shadow zone. And that will be year specific, and you'll use it to inflate the CVs on that year. It doesn't go into the informed prior on the cue. Target identification, well again, I wasn't using any acoustic estimates from surveys of layers that had Orange Roughy and other species. That's not used at all because it's just too dodgy. Target identification is spawning plumes. We know the 99% Orange Roughy. Just to show you one of the priors that was used for the acoustic cue is South Chatham Rise. This was when all 3 aggregations were surveyed. So we had most of the spawning biomass being surveyed. I don't have the target strength PDF, but this is the one for proportion of spawning stock biomass. Oh, there it is. Okay. Sorry, there is a delay on the laser pointer. Right. So the x-axis there is proportion of spawning stock biomass. It's a beta distribution. It has a mean of 0.8. So I'm saying that given we've surveyed all 3 aggregations, my prior belief is that we're getting about 80% of the spawning stock biomass. And I think it's highly likely that we're getting at least 60% of it. So that's one factor. The target strength uncertainty is the other factor. Treat it as independent, combine them, and you get this prior to the acoustic cue has a mean of 0.8, CV of 0.19. And it can go in, and I put it in as a log normal for most of them. So that's how we're getting semi-absolute. So they go into the model as relative. They go into the model as relative, but we have the information on the cue. And we have a computer thinking away. Right, we've done it. So the assessment results are driven by the acoustic estimates and the informed prior on the acoustic cue. That's the whole semi-absolute thing. But there's this M is an issue. We have M estimated by catch curves from early data from near virgin populations and came out as 0.045. Now ideally we'd be estimating M within the model, but these models for each individual stock, they don't have a lot of age frequencies. So at this stage I've just gone with M fixed at 0.045. But M matters. And the mean on the prior for the acoustic cue matters. So every stock assessment had two sensitivities that were always done and are double whammy sensitivities. 20% increase in M, so that's putting up your productivity. 20% decrease in the mean of the prior, so that's putting up your biomass. So they're both going in the same direction, and so I call that one the optimistic sensitivity, and then you can send them both the other direction, the pessimistic sensitivity. So in West Coast parlance, these are the M and the mean on the prior of the acoustic cue are the major axes of uncertainty. Just to finish, I've got some results for the East-South Channel rise. This is the base model, sporting stock biomass trajectory. It's in terms of percent B0. The plot starts quite early because we're bringing in the estimated year class strengths. As you can imagine, we've got age frequencies with fish 80 years old in them, so when we estimate the cohort that was born 80 years ago, the model actually starts quite early. This is a box and whiskers plot, so for each year we're looking at the marginal posterior for spawning stock biomass in that year. The line is joining up the medians, the box is the middle 50%, and the whiskers are going to 95% credibility intervals. So it produces a nice plot. I've marked some lines. When the assessments were done, the target was 30 to 40% B0. Soft limit when you start getting worried, 20% B0. Hard limit when you start closing things, 10% B0. And according to the base model, it's suggesting we've been between 20 and 30% B0 for quite a while, and we've only just started heading up.
Why it's so slow? I think it's the presentation view you're using. It really slows it down.
Right.
These aren't exactly complicated graphs.
No, the presentation view gives me a pointer and the next slide as well. Yeah.
Went too far?
Yeah. So I mentioned those two sensitivities. I like to call them pessimistic and optimistic, but the working group didn't like that. They are low M, high Q, high M, low Q. The point about them, if you look at the base, so that's a fixed M of 0.045, and it's estimating stock size 30% B0, 25 to 34. These two sensitivities span the whole range of the other sensitivities. So we had an estimate M model. So, you ask the question, well, what happens if you estimate M? Well, in this stock, it comes out lower, stock status comes out lower, but we're still almost certainly above the 20% B0. But we don't really believe we've got enough information to estimate M in this model, so we don't do it in the base. Cordue coming into existence in 2007 rather than 2002, it makes a difference, but it's not as bad as the pessimistic run. So the pessimistic and optimistic run are spanning things. So, you look at the base and you say, that's okay. You look at the pessimistic run and you say, well, that's not too horrible. We're almost certainly above the soft load. So that's okay. I mean, you can arbitrarily make it more pessimistic, but 20% error in two assumptions is actually quite pushing the envelope relative to a lot of assessments. So in summary, the keys to success. Well, you know, spent a lot of time looking at what had been done earlier, what data were available, and what data could be made available. I mean, that was crucial. We had to get new age frequencies with a new protocol, a new conceptual model, a high data quality threshold. So as a number of people on the West Coast will know, my approach is not take all available data, put it in, let the model sort it out. My approach is look at each data set very carefully. And the acid test is, if you include this data in the model, will you get a better stock assessment? Does this data contain information? So my stock assessments tend to have less data, not oodles of data. I want to get good quality information in there. Without the age frequencies, of course, we couldn't estimate recruitment patterns. We would have been in big trouble, so that was essential. The more accurate estimate of target strength, essential. The Bayesian modelling is essential so that I can get in the information into the informed wire with my semi-absolute acoustic indices. And yeah, that's how I did the modelling. The modelling was successful because the industry had invested heavily for many years. The industry were invested in getting these stock assessments done. MPI wanted to get the stock assessments done, and NIWA came on board doing all the age frequencies. So yeah, it wasn't me, it was a team effort. And yeah, now if there are no objections, we're only a couple of weeks away from 3 stocks being certified. If there are objections, we're going to wait a bit longer. So thank you.
Okay, yeah, we got time for, if nobody's coming in to kick us out of the room. I think the next event in here is the seminar at 12:30, so got time for questions.
Did you have more than one partition in the base model? In CASAL terms, do you have different locations for the different?
Well, the partition, as we call it, is basically just a big multi-dimensional array where you keep track of the numbers of the fish at age, in stock A, that are mature, that are in area B, etc.
Okay.
So
it's all one big population. It's broken up into these pieces.
Yeah, because you're keeping track of the numbers of fish in each of those categories of fish. So fish categorized by age, maturity state, stock, area, and whatever else you put into the partition.
But what were they, within the, say, the East and South Chatham Rise, what were the area parts of the partition?
Okay, base model and the East-South Chatham Rise. Yeah, I think except for in the sensitivity where we assumed Rikohu had existed forever, that was a multi-area model because I had to specifically put in Rikohu and the crack and the old plume.
Yeah, okay.
But in the base model, I don't need multiple areas. It's just one area.
Okay.
Because when we're looking at spawning biomass, well, they're just in this spawning.
And some of them are in the crack and some are in the plume and some.
Yeah, but that doesn't matter. That's
okay.
dealt with by using different priors on the acoustic cues.
Yeah. Okay.
Because I have those years where all 3 areas were surveyed, I have estimates of the relative proportion in each area, and that can feed into the cues when you've only got 1 area surveyed.
Yeah, okay.
So most of them tended to be 1 area, but you can make the castle models, you just specify how many areas, how many stock. I mean, that's something I just realised in terms of getting at M. If I'm willing to make the assumption that M is the same for all stocks, then I can put in that early data from those virgin stocks and I can run a huge multi-stock model and they can just share M. So I'll have lots of age frequencies with which to estimate M. That's one thing I might do next time.
Could I just follow up on M? If you have all that early data from your stock, it seems as though potentially you could get a pretty decent catch-curve estimate of it. But you said there's not enough information.
It's a decent catch curve estimate, but it's not a decent estimate, really. because you're not correcting for the recruitment variability, which is the main issue.
But over all those years, you know,
No, were just single year. The early data from the age frequencies from the near virgin populations are just single year, just 1 year from each of 2 areas.
right.
And isn't the recruitment estimates are that there's been some pretty highly autocorrelated changes in recruitment, right?
Oh yeah,
I mean, that's the problem with the catch.
Yeah, so I did 4 assessments. 3 out of 4 assessments, if you assume deterministic recruitment, you just get ridiculous answers. One of them, the recruitment variability wasn't very high, and you would get away with deterministic recruitment. And that's the problem with the catch curves. But the way to fix it is put that data in for a stock. So I've got 4 stocks, I'd have another 2 stocks, they'd each go into their own stock, they'd have their recruitment Ds that you'd estimate, and so you'd be adjusting for recruitment variability, which is the way to do it.
You had said that you were not a biologist. It seems that in order to have been successful in this, you need to know a lot about math, a lot about acoustics, and a lot about the biology of the species. So do you possess all of that information yourself, or other people helped you with that?
Yeah, these assessments and all previous assessments goes through the Deep Water Fishery Assessment Working Group, which has scientists from a number of research providers, there's people from MPI, government, there's people from industry, including for a very long period of time consultants from UW attending. So I've been involved with Orange Roughy and those working groups for decades. So I have absorbed biology from other people. So my conceptual model, supported by data, and not completely ridiculed by biologists. In fact, Matt Dunn did suggest that, Orange Roughy, you could think of them as a bit like rockfish and protecting our territory. So it's not inconsistent with some of the ideas biologists have about it.
Okay, well, Patrick, thanks very much. And that was really, really interesting, and we'll be interested to see what happens to the certification. As you probably know, the MSC, the team that was reviewing this, the stock assessment was reviewed by Andre Hunt. So he's got a reputation as being pretty tough.
Well deserved.
Yes. Although I have to say, Patrick has a reputation on the West Coast as being pretty tough as well when he comes for the CIA reviews.
What does it stand for, CIA?
Committee of Independent Experts.
Center.
Oh, Center for Independent Experts. Ah, that's right. Center.
And so they provide experts not paid for stock assessment,
I'm going to shut down
all sorts of things.
Yeah, but mostly stock assessment. Mostly stock. Let's stop recording.